Let's get ready to rumble. Okay, so here we're looking at a moving conductor problem, which is going to generate an EMF. This is actually Intergalactic for Chapter 21, number 18. And the problem goes like this. Fleeing from the intergalactic overlord Reztob, you jettison some space junk. Long 2-meter rods of iron, moving at 200 meters per second. 200,000 meters per second, more like it. Luckily for you, the junk has been jettisoned near a Magnetar, which is a rapidly rotating neutron star with a magnetic field of 500 megatesla. That's mega T. Seeing that the EMF generated is dangerous, Reztob calls off the pursuit. What is the EMF you generated along your iron rods, and how does this compare to a bolt of lightning? Well, let's take a look. We know that if we have a long rod, and it's got a length here of 2 meters, and this rod is moving through a B field, so moving with some velocity through a B field. We know that the EMF generated on this rod is going to be equal to BLV. We don't need to worry about any cross products for this problem, just everything will be nice 90s. But we're going to have a BLV here. And if we just take our values and multiply them together, we actually have everything here. We know the B field of the Magnetar is 500 megatesla, so that's 500 times 10 to the 6th Tesla. The length is 2 meters, and our velocity is 200,000 meters per second. When we multiply all that together, we get a final answer of, what is this? Let's see. 500 times 10 to the 6th times 2 times 200,000. We get 2 times 10 to the 14th. And because this is an EMF, this is in volts. And that's our answer. Okay? A typical bolt of lightning, I think, has 100 million. So I think this is something like 2 million times greater than that of lightning. I think it's something around that. I think it's around 2 million times greater. Which means that, if you had some, let's see, V to B, if you had some positive end of your rod and some negative end of your rod by a right-hand rule, the EMF generated across that is a lot. So if this accidentally struck the ship or something like that, you don't want to accidentally be the wire which that's this EMF running through. Okay, so that's just a quick way of doing one of these little problems. There are all sorts of other variations of this that'll pop up, but this is just a quick one. If you're ever fleeing in space, it's a nice thing to do if you're around a Magnetar. Okay, and just a little side note: these Magnetars are around rapidly rotating neutron stars. These neutron stars are hyper dense. They're super dense, and they actually have this super strength magnetic field looping around them. And what will sometimes happen is on this B field, they'll actually kick out like jets of particles or jets of radiation, and we see these as pulsars. Oftentimes these are like radio burst pulsars that we can take a look at, and they can spin very fast. You can get like 500 rotations of the pulsar every second, which is a kind of crazy thing. But they're like hyper rotating, they're super like condensed and packed, so kind of cool stuff, just on the world of space. But with that, this problem is finished. Adios, and you all take it easy.